We know from Calc 2 that work is force times distance, and we can actually break that up in little pieces so the force isn't always constant. But one thing we always had to have in Calc 2 is that the force and the distance are always going in the same direction. We want to generalize this a little teeny bit so that by the end of the semester we can actually calculate work done on very curvy things where the force constantly is changing directions and changing size. But our first step is just calculate the work done when we want a force to be pushing something from here to here, but where the force itself is not actually in that direction. Well, you'll see this a lot in physics. What I want to know is how much of this force is actually going in this direction. Well, that's just the projection. And this is going to be a number, right? The length of this is just going to be force dot d over length d. And that would just be the size of the force that's actually going in the direction I want. And what do I want to do? I now want to, it's going to be force times distance. There's the force. The distance is just going to be length d. Like that. So that will absolutely be the work done because it's the force times the distance. This cancels very, very nicely like this. And what we wind up getting is just force dot distance. Even it looks like force times distance. It's pretty cool. That means almost anything we did in Calc 2, we should be able to easily replicate in Calc 3, but where the force actually isn't going in the same direction.